All right, in this video, we're going to be modeling a airfoil in a wind tunnel and use Fluent on it. So the best way that I know to do a wind tunnel with an airfoil in it is using a separate CAD program for your geometry. I'm not sure how to do it in Space Claim or Design Modeler. So what I'm going to do is I'm going to load up Fusion 360 and I'm going to design this wind tunnel. And you can see I've already put an airfoil in there, but I'm gonna do that from scratch. I'll show you guys how. So first thing we're gonna do, new design. Create our sketch. And so there is a script you can get to import airfoils, any NACA airfoils into Fusion 360. So I've already have a 2412 loaded up. I'm gonna do 120 points per side. All right, let's look at that. So sometimes the script will not put it on the plane that you're looking at or that you're sketching on. Finish sketch and go back to the home. You can see they sketched it on the top plane. So it's always best to do your airfoil sketch first because now, let's delete this. Now we know we have to put our airfoil or our wind tunnel here on this top plane. All right, we're going to create a new sketch and we're going to use same from the last video, the same specifications. Oh, very important. Let me make sure I'm in the right units. And you do that by going over here to document settings, changing the units right here. So just going to go ahead and quickly create this. Okay, now that we've finished the sketch, let's go back and scale up our airfoil. So now we can see like how small it is in the test section. Let's just scale that up a little bit. We're going to do that by going to the airfoil. Let's go to modify. Let's do sketch scale. Select all of our points, 723, except the one here at the origin, because that's going to be our pivot point. That's the scale point that we're going to scale from. So I'm going to scale it up. Let's see how 5 times looks. And scale it up 9 times. So now that's how that looks in the wind tunnel. You know what? Let's do 8. Looks a little bit. That looks good. So now this is pretty important. What we're going to do is we're going to extrude our airfoil. Doesn't matter how much you extrude it. the new body. And then now we're going to make sure we extrude our airfoil as well. Just make sure they're the same distance, so that way you get a cutout of the airfoil. That's what it's going to look like. It's going to look like this. So to get it over into Ansys Fluent, we're going to File, Export. .412.3. So a sat file works fine. A .sat. Let's export it. So now we're ready to bring it into Ansys. All right, so let's go ahead and create a new module. Right click on Geometry, Import. Find wherever you imported that, open it up. All right, so now we're going to go into Design Modeler, and we're going to make sure that it is imported correctly, and we're going to create a surface. Because right now we have a solid body, and we're going to do a 2D analysis, so we don't want a 3D body. So now we have here, we can see our import in the outline tree. It's a lightning bolt, so let's generate that. Let's see how it came in. Oh, it looks beautiful. Center down here. All right, so if you open up your tree, let's rename this as solid body. All right, now let's go up to concepts, and we're going to go down to surfaces from faces. All right, and to select our face, let's do that. Select our wind tunnel, generate. And now we can see we have our surface. Now I'm going to rename this as face. And then we're going to want to suppress our solid body. So now we're left with only our face. Generate, make sure we're good. Save that. All right, now let's bring it on over and let's do our mesh. All right, there we go. We can see our airfoil has imported over our mesh. Now let's just go ahead and set our values. I'm going to use for an element size 0.002. I'm going to use triangles as method. And then I'm going to get, this is the difficult part. I want to get a finer mesh around our airfoil. So what I'm going to do is I'm going to select sizing so we can get smaller size around here. We're going to go up to our bar, select edge, and hold shift. And now just kind of like paint around the airfoil. And there are so many edges that it's difficult. You got to make sure you get them all. There should be like 240 edges or something. I did this one before. So let's just make sure we highlight everything. Everything should be green. All right, let's apply, see how that is. So I missed some. So it looks like, oops, missed some here at the back. And it deselected everything. So yeah, this is a bit of trial and error. Make sure we get everything. I must have clicked before hitting shift control. The fun part is we do this again to name our airfoil for our solution. All right, I think I got them all this time. There we go, 240 edges. Yeah, that looks good. Okay. I don't know what happened. All right, we'll roll with it. So anyway, let's go ahead and generate our mesh. All right, here we go. We have our mesh, pretty small mesh, and it's not bad here around the center, but could be better. So let's change our element size on the size edging 0.0009, and we want to make sure that that's per the problem. We want it to be hard behavior. That means that it can't edit the shape of the airfoil at all, and it's meshing. All right, here we go. We can see the element size is smaller here around our airfoil. If you really wanted to, you could add some inflation. I think this will be okay. So the next thing we have to do is get our named sections. So I'm going to highlight your edge. Same thing as last time, last video, inlet. The hotkey is N, by the way. So now this is the fun part. Selecting the edges again. Make sure you hit them all. All right, there we go. Now we have our mesh. We have our named sections. Looks like I got everything in here. Let me double check real quick. Okay, let's check our tunnel walls. All right, we're good. We're good. So next thing, let's update this. Make sure we bring it into our workbench. And then we're gonna do our setup and solution. All right, it's double precision. With my computer, I can use 3 cores for my solver processes. Choose whatever's good for your computer. It's probably gonna be super slow because Zoom always seems to slow down the solver. Wait for it to load. And then here we can see it's loaded. Our airfoil's in there. We're good. Looks like our inlets and outlets are already set. Pressure base, because we're subsonic. All right, let's check our models. I'm gonna turn energy on. Change my solver to K epsilon. Use a standard for everything. Check the materials. Let's just make sure air is good. Just make sure our boundary conditions are set. Our airfoil's a wall, inlet velocity inlet, outlet is pressure outlet. Let's change tunnel walls to symmetry. And wall face. I don't know where that came from. Velocity inlet. So we want to try to get a velocity in the tunnel section of about 12. So I'm going to use 3.18 as my velocity magnitude of the inlet. That's meters per second. So yeah, make sure we want 0 gauge pressure. Walls, symmetry. Our airfoil is going to be stationary. No slip condition. All right, and let's do our methods. Simple. Presto pressure. Initialize. The 10 should be fine. There we go. Now let's run our calculations. For this video, I'm just going to do 200. For my actual analysis of the project, I'm going to go back and I'm going to do more. So that we can see it's off. Now we can go and see our contours. Let's take a look at velocity magnitude first. So you can change the numbers on your scale over here just by going over here to type. I like float. Zoom in and check out our airfoil. Yeah, that looks about right to me. You can see the velocity of the test section it's about 12. It's somewhere within that range. You can see that there is no slip along the edges of the airfoil, and it's a relatively minimal profile. You know, there's no not a lot of turbulence coming off this airfoil. You can see there's the stagnation point right here. So it's pretty good. And here's our static pressure. Yeah, you can see there's a lower pressure up here on the top, a higher pressure here on the bottom. Getting some lift. A little bit, not too much. It's a pretty low speed, but looks pretty good. Yeah, and you can see here these points. That's because it's a pretty rough geometry right here. It's not very smooth. It doesn't slope in, so that creates not a very smooth flow going in. It kind of creates a little bit of turbulence. Then if you wanted to see the streamlines, let's go X this out. Let's go back to our workbench. So this is closed out. We go to our results page and check out our streamlines. Just wait for this to load in. Takes a second. It's down here on the bottom right. There we go. Center in on it. Then it's going to be up here in your toolbar. It's going to be a third over after location streamlined. So let's start from our inlet. Let's do 200 points. Let's generate it. Takes a second, and here we go. Here's our streamlines. We can zoom in. Here's our streamlines around our airfoil. You can rotate it, see it in 3 dimensions, but we're in 2 dimensions, so. Yeah, you can see how the velocity slows down in the wake of the airfoil. So, yep, that's how you do an airfoil in a wind tunnel in Ansys Fluent.